Hello everyone, my name is Mekael Wasti and welcome to this quick demonstration of what I have been working on over the summer as a URA student. My project is Machine Translation Error Annotation / Post-Edit System with Reinforcement Learning from Human Feedback. The project is supervised by Professor Annie Lee and Professor Christopher Collins. The scope of the project is larger than just a summer, so I will be covering what has been done thus far. As a quick overview of the project, the goal is to make an error annotation post-edit system that conducts machine translation and error span detection. The system then outputs and displays these inner workings to the user, where they can evaluate the quality of the translation and machine error detection, as well as insert their own error spans and/or make textual adjustments to the translation output. So as the project is still in progress, we will quickly gloss over some of the constituent parts. Machine translation is an obvious foundational component. For now, we carry out Chinese and English translations both ways, and this leverages Meta's NLLB model. This backend pipeline flow diagram that I'm about to show you will help explain the subsequent processes. So user input is passed to the NLLB model. This model's translation output will be passed to two NLP models by the company Unbabel. These models are state-of-the-art solutions to multidimensional quality metric scoring, which determines the overall quality of the translation compared to the user input, which is a reference, as well as fine-grained error detection models, which give more detailed spans and error detections. However, XComment does not classify the error into an error type. This is where we leverage GPT-4o API to take all the aforementioned information and use it to simply classify the error type given a list of errors that we support. Spans are then scored through methods such as F1, recall, and precision. All this then gives us a combined evaluation of the machine's translation and error detection job. Then we move on to the front-end component, where the user gets to perform their post-edits and evaluation. We have highlighted spans to mark each error segment, and they are mapped between the original and translated output for easy reference. Collisions and overlaps are handled dynamically through our span injection algorithm. The user can hover over each span and get a tooltip that is populated with that span's specific details. The user can also click on a span to get a dropdown from which they can reclassify the span if the error type was predicted wrong. Then we have the edit context area, which again is still under construction, but it allows the user to insert their own spans as well as make edits to the translation. They can add and remove text, which will be reflected in a suggestion format on the actual translation output area. The user can select each span and score its quality individually, as well as provide an overall score for the translation as a whole. Once they are satisfied, the user can submit the translation back to the system, where reinforcement learning processes would use the feedback to iteratively improve. Finally, we recently submitted a research ethics application so that we can conduct a human study and get a human evaluation of our system. That's all I have for now. Thank you for listening.